Let's take a look at what it means for it to be a function or not a function. So if we look at the first problem here, ordered pairs 2, 4, 2, 5, and negative 6, 7. So those are ordered pairs. In other words, they are points. So if we sketch out maybe just a rough sketch of a y-axis, x-axis, and we think about where those points would be located. So if we think about 2 and then 4, 1, 2, 3, 4. So 2, 4 would be right here. All right, so that's this point. And then the next point, xy value, would be 2, 5. So 2, 5 would be same x value, but 5 for the y. And then negative 6, 7. Okay, so negative 6, 7, if we extend back here, 1, 2, 3, 4, 5, 6, negative 6. And then what, 6, 7 up here. So it'd be roughly up here somewhere as the point negative 6, 7. And we are supposed to take a look to see whether that is a function or not. So basically, if it's a function, that means that each input, so in this case like negative 6 over here, goes with exactly one output. So that is true for that point. But notice over here that when we get to the x value of 2, it goes to more than one output. It goes to the 5 and to the 4. Okay, it goes to an output of 4 and to an output of 5. In other words, it does not pass what we call the vertical line test. If we can draw a vertical line through the graph and it only ever crosses the graph or the points once, then it is a function. If you do a vertical line and it passes through the graph more than once, so in this case it passes through both of these points, then it is not a function. That means the input goes to more than one output, and that is not a function. So no input of 2 has more than one output. So not a function. All right, let's take a look at the table. So we could do something similar with the table. We could graph it out. But I'm just going to kind of use the idea, okay, so negative 1 is an input, it goes to 5. 0 has an output of 3. An input of 1 has an output of 4. An input of 2 has an output of 7. An input of 3 has an output of 4. Notice each one of these inputs goes to exactly one output. All right, so each input has only one possible output that it could ever go to. So in this case, yes, it is a function. Each input has exactly one output. So that is a function. All right, C. Okay, so this is one of those problems where it's pretty easy to use the vertical line test. Once again, if you take an input, so something along the x-axis, let's say, once again, let's take an x value of 3 here. We can see that 3 goes to an output on this circle graph up here, but 3 also goes to an output down here on the circle as well. So 3 has an output here, a y value, and 3 has an output here. So it does not pass the vertical line test, and we can see multiple places if we draw vertical lines that it crosses the graph more than once, which means the x values in those places have more than one y value for an output, so not a function. The graph of a circle is not a function. So no multiple inputs, in other words, x values, have more than one output. In other words, they're y values. Okay. All right, in D over here, this is the graph of the absolute value function. We may have seen it just briefly earlier this year. So if we think about x values like an x value of 0, there's a point, an x value of, say, negative 3, there's the output for negative 3. If we take an x value of, 1, 2, 3, 4, notice it goes up to the graph right there. And everywhere we pick for an input, it only has one output for that particular input. So if we do the vertical line test, everywhere on the graph we draw a vertical line, it only ever crosses the graph once at a time. All right, so each input, each x value that you put into this would only go up to the graph and correspond with one output. So this is a function. So yes, each input has exactly one output. Okay. So that's the idea of kind of how to identify a function from ordered pairs, from a table, from a couple graphs. And when we talk about inputs and outputs, we're going to start to use these other terms here also, domain and range. You will hear these terms eventually when you go into Algebra 2, pre-calculus, calculus, if you continue on your math up to those classes. For sure, all of you will have at least Algebra 2. And so when we have these ordered pairs, again, kind of think of them as x, y's, input, output. So the domain is just a special word that represents all of the possible inputs, okay? In other words, all the possible x values. So we defined that before, but all possible inputs. Now there's a little like notation that we use. So if you're going to do the domain, sometimes you just use letter D. You use these kind of brackets, these curvy brackets here, and you list the possible x values. So in this case, 2 is a possible input, and -6 is a possible input. Notice I don't list 2 twice because I'm just listing for the domain what are the possible inputs. Well, 2 is a possible input, and -6 is a possible input. So generally list those. And sometimes we list them in order from least to greatest. I guess I didn't really do that there, but that's okay in this case. All right, and so then the range is simply all the possible outputs. If I could spell correctly here. So all possible outputs. So the range, again, so we'll use this little bracket. I'll use a different color, but we got 4 and we got 5 and we got 7. So 4 is a possible output, 5 is a possible output, 7 is a possible output. So that would be the range of this function, or the range of these ordered pairs. All right, so let's take a look at the table. So all of the possible inputs, here they are. So we can represent the domain with those values. So -1, 0, 1, 2, and 3. And then the range is all the possible outputs. So I don't know, if I'm putting those in order, I'm going to try to do that here. So we've got 3, cross that one off. We've got 4. Now 4 is there twice, but I don't have to list it twice on the range because I just am listing the possible outputs, and 4 is a possible output. 5 and 7. Okay, so it is generally best to list those in order from least to greatest. It makes it a little bit easier to understand. It's not like we're making a table anymore. We're just listing the inputs and outputs. Okay, so how would that work for our graph? So again, the domain is the possible inputs. In other words, the x values. So I want to take a look here at the x-axis and notice that the graph goes back to this spot right here. So that's kind of the barrier here. That's where the graph ends on the negative x side, and then it goes to positive x values up to this point right here. So let's take a look at what that is more closely. So that'd be 1, 2, 3, 4. So this is -5 and then +5, right? 1, 2, 3, 4, +5. So the domain in this case would be all possible x values. Now notice, it's not just like -5, -4. The graph itself is continuous, so it goes to any point between -5 and +5, including all the decimals. Like there's a point on this graph somewhere that has an x value of -4.6, like, you know, somewhere roughly right around here. Okay, so it has some decimal values along the way. It's not just whole numbers, it's continuous. And so to show that, what we're going to do is say, all right, all the possible x values, all the possible inputs would be between -5 and +5. So we're going to show that by using our less than or equal to signs. So -5 is less than or equal to all of the x values, and all of the x values, all the inputs, are less than or equal to +5. So basically it's saying all the inputs could be anything between -5 and +5, and also including -5 and +5. Now let's think about how that would work with the range, or the outputs. And with the range, we're thinking about the y values. So if we look carefully at the y values here, we see, okay, it reaches its maximum y value right there. It reaches its minimum y value down here. Once again, this graph is kind of symmetric. So it goes from -5 to +5 on the y-axis also. So the range works similarly, only now we're talking about the outputs. So the y values are anywhere between -5 and +5. That would be the range. So any number, including decimals, including fractions, between -5 and +5 could be part of the range. All right, let's take a look at our last one here. We have, once again, thinking about our domain and thinking about all of the possible x values. I guess I'll keep color coding the same, right? I guess I've gone with blue for domain for whatever reason. All right, so domain. So the x values here, notice this arrow. We think about this graph. This graph is going to continue on in both directions forever and ever and ever. Okay? Is there ever a possible x value over here, and ever a possible input that this graph will not reach? No, eventually we will be able to, if we could extend this graph off the page way up here, keeps going on forever, eventually we'll cross with that particular input, right? So the x values for this function here could be really infinite. All right, so all real numbers between -infinity and +infinity, and I think I'm going to represent that with a little infinity symbol here. So a little infinity symbol is kind of like a little sideways 8. And so all the possible inputs would go between -infinity and +infinity. So there will always be an x value that you can match up with a y value for this particular graph. If you could make an infinitely sized absolute value graph, you would eventually get to that possible input, and it corresponds with a possible output, in other words, a range value. Okay, but let's just think carefully about what it means for the y-axis. Does this graph also get to infinite values on the y-axis? Well, it does in a positive direction, because this just keeps going up forever and ever and ever. So it will eventually get to whatever y values we want on the positive side, but it does have a minimum at 0, right? 0, 0. So it will never reach any of the negative y values. So in this case, 0 is kind of like the bottom of our graph, right? It never gets below it. But the range could be anything above 0. So 0 is less than or equal to y. So we could say something like that. But I think it would probably be better if we also said is less than or equal to infinity. So the outputs, the y values, will reach into positive infinity, but they will not get lower than 0. So 0 is the bottom, so that's why we put that as the lowest part of our range, the minimum.